Now that we've learned how to write reactions and do a few other skills and kind of what those chemical reactions look like, we're going to talk about classifying chemical reactions into certain types and certain patterns. And I'm actually going to break 8C into two different sections. First, we're going to do the types, and then we'll pause, and then we'll do predicting different types of reactions. Okay, there are 5 major types of chemical reactions, and most of the ones we're going to see in the majority of this class are going to fall into certain categories. What you should be able to do, number 1, is identify or describe the type of reaction. Look at a reaction and tell me what type it falls into. We also should eventually predict the products. That's going to be in part 2 of this section. Okay, where if you're given reactants, can you predict what the products are going to be? All right, the first one is called synthesis. Synthesis reaction is the combination of 2 or more substances to form a compound. And the term synthesis makes sense here because synthesize usually means to put together or to form. And there's typically only one product. Now, I'm oversimplifying things for the purposes of Chemistry 1, but if we can get good at these categories and you take chemistry later, you'll learn to broaden your perspectives a little bit on this. And this is the generic form when you have 2 different reactants coming together to form one product. And you're going to see that these patterns are going to be the easiest way to identify what type they have. And then on the bottom is just an atomic, model or version of this. So for example, you have hydrogen gas and chlorine gas that are part of Hunkel fiber, so we have to keep them as diatomic, coming together to form hydrochloric acid. This is just in a reaction of what you would see for that, where you would bubble those gases into the substances and get them to react. Okay, then you have decomposition is type number 2. Decomposition, hopefully we've got a decent idea of what that term means even before we formally define it here. But a decomposition reaction is where a compound breaks into 2 or more simpler substances. So even if you think about decomposition in biology, you're taking something big and breaking it back down. Decomp in chemistry is going to be pretty similar to that. And usually for the purposes of this class, we only have one reactant and we're breaking it into simpler substances. So for example, my one reactant would usually be a compound. Okay, here's my bad abbreviation for compound. And then we take that compound and we split it into the elements. Again, we stick to some of the more straightforward ones in Chem 1, but if we get that basis, then we usually can build off of it in the future. Okay, now for example, if we took water and we decompose it, the only 2 options are to split it into its 2 elements. The only curveballs being that we have to remember that hydrogen gas is diatomic, that oxygen gas is diatomic, and then what that looks like. Okay, and in order to get water to break down, we have to this is electric current that we have to pass through it, because in a good way, water does not just spontaneously break down. We have to put enough energy or electrocute it to force those bonds to break. Okay, then we have what's called single replacement. Single meaning one, replacement meaning to replace something. So this is when an element is going to replace a similar element in a compound. So what does this look like? There's a couple of options. You can either, when I say similar, you're going to have a metal replace a metal, or hydrogen. And that makes sense because metals usually form cations and hydrogen also forms a 1+ ion as well. Or you get a nonmetal replacing a nonmetal, and in that case it's the anion replacing the anion. This is the general term. Again, the big kicker here is that for both your products and your reactants, you have an element and a compound. So even if you just get used to identifying how many reactants or how many compounds and elements there are for the reactants and products, that can usually go a long way in helping you identify what type of reaction that you are dealing with. Okay, so this is just giving you the arrow here where this A is a metal and it's going to kick out the metal and then it's going to set it free, so to speak. So we'll talk more about that when we talk about predictions. And this is just an example where you have copper solid, you put it into a solution of silver nitrate. The copper is going to undergo some electron transfers here and give away some of its electrons to form a copper 2 ion so that you get copper 2 nitrate, and then you would get silver metal plating out of the reaction or precipitating out of the solution, and we'll see several of these. Okay, so again, this is just showing you what that would look like. Those little crystalline things that you see in there are the silver being deposited, and we'll see some of these reactions over the course of the semester. Okay, double replacement. We're still talking about replacing things, but double means we're going to replace two of them instead of one. And so the general form on these, and I have a feeling these should have done these two slides. I'm going to scoot forward and then come back. Yeah. Essentially, in double replacement, you have ions and two compounds change partners or flip-flop. Okay, so you have two things change spots. So the cation of one compound combines with the anion of the other. And the big kicker on this one, is that you have two compounds on both sides of that arrow. I'm trying to write with the mouse here. So you got two compounds as products, two compounds as reactants. Okay, and again, you just get them to switch. So the cation of A is now going to pair up with the anion of D, and the cation of B is going to pair up with the anion of C. So they just, I'm sorry, no, let me fix that so that it's correct here. Probably, maybe I said it correctly, I don't know. But you've got a cation and an anion, and then the cation and the anion, and then they're going to switch. So you're just going to, A and the C, you're going to switch places. So there you go. It's got the little arrow. And again, two compounds on both sides of the reaction. So if I come back here for just a second, here's an example where you have lead nitrate combining with potassium chromate, which is the yellow color. And then what you end up with, excuse me, is the lead 2 chromate is a solid. It precipitates out of solution, so you know a reaction took place. And then you still have the potassium nitrate floating around. So that's an example. And here's my other slide. Okay, the last type, that should say number 5, not number 2, is what's called combustion. These are our fan favorites because usually this involves fire. This is the burning of any substance in oxygen to produce heat. Okay, so the kicker here is oxygen. Okay, if you have oxygen as a reactant, you can classify it as a combustion reaction. And sometimes you actually can get some things to be both combustion as well as synthesis is usually the most common, but you can't have one reaction fall into more than one categories. And this is an example of methane, right? Methane is one of those alkanes that we need to be familiar with. And any time you have a hydrocarbon or any of those alkanes and you burn them in the presence of oxygen, the products are always, we're going to come back to this later, carbon dioxide and water. Okay, always carbon dioxide and water on those. But you've got methane reacting with the oxygen. We've got our carbon dioxide and we've got our water. Okay, here's a summary chart. This is kind of what I was talking about, where it's a nice summary of figuring out what type of reaction you're dealing with, just looking at the numbers of reactants and the number of products, because synthesis, you always end up with only one product. Decomp kind of is the opposite. You have one reactant, you split it into lots of products. Single replacement, you have an element and a compound on both sides of the reaction. Double replacement, you have two compounds on both sides of the reaction. And then the big kicker for combustion is oxygen. Okay, is oxygen. So I'm going to go ahead and stop right there. I'll do predicting products in the next video.